Hi, this vodcast is all about using data to make predictions. We're going to make two kinds of predictions, interpolations and extrapolations, and we're going to use Fathom to help us. And to get some data, we go to the library. Here's a shelf with 15 books on it. If we measure how long the set of books is, we see they're 36.6 centimeters. You can see where we might be going with this. We can go to different shelves, count the numbers of books, measure the lengths of the sets of books on the shelves, and enter the data into Fathom as we've done here. If I make a graph, think quickly, what goes on the horizontal axis? The answer is books goes on the horizontal axis. And these lengths are in centimeters, though I have not put units on them. If I do this, I see what's probably not surprising. Notice how the more books there are, the longer the set of books is. Let me put a movable line on the graph. When I do that, I can make a reasonable line that kind of sort of approximates the points. Couple things to note right now. One, these points do not lie exactly on the line. Think for a moment, why not? Next, big question, should the line go through the origin? It looks like it does, but if I look at the formula, I see it doesn't exactly. Well, if there were no books, there would be no length. So let's make it go through the origin. I'm going to right-click and choose Lock Intercept at 0. Now, it's just length is 2.32 times books. Okay, time to move on to prediction. Now, in statistics, prediction is not always trying to see into the future. Here, for example, let's make up this problem. We want to know what will be the length of 10 books. There are two ways to get at the answer to this. One way is to look on the graph. If I just point at where it would be on the graph, I can see this 10 and I move up to the graph and I point and I can kind of guess that it's going to be something like 25. But in fact, I can look down here in the lower left-hand corner and see the coordinates of the pointer. Now, in case you didn't know, these are the coordinates of the tip of the arrow. So if there were 9.78 books, there'd be 24.54 centimeters. And I can move this a little bit to try to get as close as I can to 10, and I can get pretty close even if I don't get there exactly. Now there's an entirely different strategy, which is actually much simpler, and that is use the formula. If I see length equals 2.32 times books, if I have 10 books, I just plug in 10 for books. I get the length should be about 23.2 centimeters. Do you think the length is going to be exactly 23.2 centimeters? Of course not. And we can tell it's not going to be because of the spread of the points around the line. So when you give me an answer for something like how long will a string of 10 books be, don't give me a single answer anymore. Give me a range of answers. And you can find them by seeing what range of slopes of this line actually makes some kind of sense. So it might be that it'd be somewhere between, say, 20 centimeters and 28 centimeters. That would be a really good answer to this question of how long will a string of 10 books be. Now, that was an example of interpolation. And it's called interpolation because the point we were looking for at 10 is inside the range of the points we have data for. Now we're going to do extrapolation, which is looking for data that's outside the range that we have. A problem which requires extrapolation is something like this. The shelves in the Lick-Wilmerding Library are 90 centimeters wide. How many books will fit on a shelf? And again, there are two strategies. One of them is to look on the graph and see where 90 centimeters is. So here I've got 90 centimeters kind of up near the top. Looks like if I go a little farther out, I can, somewhere around in here, 35-ish books is going to be 90 centimeters. But once again, I can also use the formula. So if I have length equals 2.4 times books, I'll have 90 centimeters is 2.4 times books. Oh, books is 90 divided by 2.4. Going to bring up my trusty computer calculator, bring it into the window. So I say 90 divided by 2.4 equals, 37.5 books. Once again, do you think that's going to be the exact number of books, 37.5? Of course not. Now I'll leave it to you to figure out what's the best way to determine the range of the number of books you would expect for a 90 centimeter shelf. Now you can use these same techniques on other problems. For example, predicting the population of the world. Good luck.